review, we just finished functions. We started with just understanding how functions work. So remember that inputs are in parentheses behind the function name, and outputs are in square brackets in front of the function name with an equal sign. You can always run the functions without outputs, but you have to provide inputs if the inputs are used in the function. If you have inputs that are never used, it actually will let you run them without the inputs. You can have 0, 1, or many inputs or outputs. So you can have a function that has no inputs and no outputs. We are going to have a lot of those. For example, quiz 5 that you just took, the top function had no inputs and no outputs, and that will pretty much be how it is every time. The top function will have no inputs and outputs so that we can run it with our script. And then the other new thing about functions versus scripts is that all the variables that are defined inside of the function are not known outside of the function. So they're not known in the command window when you run it, or if you run it in another M file. And that's what the term black box means. It means there's inputs and outputs, and that's all you really know about. You don't know about what goes on inside a function when you run it. The last thing, and this is very important because this is probably how every single quiz will be submitted from here on out, is that you can put multiple functions in one file. So when you run a file, you want the name of the file to be the same name as the first function, the top function. So when you run that file, this function runs, and if any of the functions below it are called, then those will also run. So this is part of the quiz 5 you just took. So I'm calling the insert function that I wrote from the main function. Okay, this is for later. We're going to do something that's very exciting because you know how you had to copy down data before? Like if I needed you to have data for one of your labs. Well, now you don't have to do that anymore. You don't have to copy like an M file with the data written in. Now we're going to learn how to read in data. So I'm going to move over to the doc. So I want to show you just a few things written out, and then I'm going to show you the rest in MATLAB. Okay. And this topic is called data management. So this is really necessary for doing real engineering problems where the data is, there's a lot of data and it's not possible to be typing it out or even to be copy and pasting it into files. You really want to store the data separately in a separate file. So MATLAB is able to read and write or import and export a variety of formats, and that's what we're going to talk about today. So the first one we're going to talk about is MATLAB's native format. And some of you have kind of run into this accidentally, I think, already. And it's called a .mat file. So maybe you accidentally saved something as a .mat file and when you're trying to save it as an M file or something like that. So that's the extension of the data file that is intrinsic to MATLAB. So if you want to, for example, import data that is stored in a .mat file, the command is load, and the syntax is that you just you open your parentheses and then you put in the file name. There's actually a variety of syntaxes allowed with a lot of functions in MATLAB. So I think I've seen many of you, instead of using parentheses, using a space and then putting in the inputs just as next to a space. that is a really bad way to get, it's a bad habit because it doesn't always work. But if you use the parentheses, it always works. So just keep in mind that sometimes you might see, or it might even give you a hint to try a different syntax, but it might not work as consistently. So if you had some data stored in filename.mat and you wanted to load that data into MATLAB, you would just type load and then put the file name in. The export command is save. So alternatively, if you have a bunch of variables saved in your workspace or in your M file, if you just write the word save and then put the file name that you would like it to go to, then it will, that's the way the export works. So I'll show you both of those things in MATLAB. But what I wanted to make sure that I paid special attention to tell you is that you now have two different types of files that you're going to be working with, and just don't get them confused. So a .mat file is a data file. This is not an executable file. It's just a file like a text file or an Excel spreadsheet file or a binary file. It's just holding data in it. So its purpose is to store data. It doesn't have commands in it that execute any code. Where an M file is a script file, and as you now know, it can also be a function file if it has a function declaration line. And this type of file runs commands or runs code. Okay, the second thing that I just want you to jot down, and this is something I'll just let you kind of experiment with when you're on MATLAB, is just look at the difference between these two types of ways of loading in data. So I'll just write it down and you can look at it, but these are both allowed, especially in the command window, not always allowed in the M files. And also, this is probably, I hope this is obvious to you, but that file, if you're loading a file, it needs to be in your current directory, and if it's not in your current directory, then you need to have an absolute path or a direct path to that file. So if you're going to go back a couple folders or something like that, then you need to use the Linux prompts, which I can show you, or just always put it in the folder. Okay, so the second type of file, or the second type of data format, I'm just going to group together as non-native formats, and we're going to use both of these types often. So some examples of non-native MATLAB, they're not native to MATLAB, is text files, binary files, Excel spreadsheet files, and a lot more. So each type of data file has a different format. So that's what I want to show you. And I always forget this, so I'm going to just show you what I always do. This looks weird. All right, so let me show you some of these things. I have a file here, and this is the file you're using for Lab 6. And so I'm just going to show you right now, if you look here in my workspace, I don't have any workspace variables right now. It's completely empty. So when I type xlsread and then type in my file name, which the tab does work to autocomplete file names as well if it's in your folder, and then I press enter. Wow, I'm having a lot of technical difficulties. Okay, it's fine. Okay, so the first thing I wanted you to notice is that when I typed this in, nothing showed up in my workspace. I mean, the ANS always shows up when you run any command, but there's no like variables that went to my workspace. So all it did was it read the file, and then that's it. It didn't save it anywhere. I have no access to it. So when you read using either a text file or a spreadsheet file, you have to put all of that data in a variable when you read it. So I'm going to rerun it now, and I'm going to set data equal to xlsread, and now all the data that's in that spreadsheet and it will only usually be on sheet 1, will go to the variable data. So a lot of times the first thing you want to do when you're reading in a file is look at the size. If it's a lot of data, sometimes it's hard to print it because you can't really see it all. So this has 4 columns and 101 rows of data. So this is the same file you guys are going to use for that for Lab 5. So oftentimes what we do after we read in data is we save the whole spreadsheet or the whole text file to an array, and then perhaps redistribute the data in a more useful way with a more useful variable name so that we don't have to constantly access that full piece of data. So for example, maybe I want to put the first column of data into a variable A, and then I want to put the second column or the fourth column of data into a different array. Okay, so that's how you do XLS read. We're never going to write to Excel files, but you can. It's the same way. So now I want to show you how that .map file works. So right now I have 3 variables in my workspace: A, B, and data, and ANS. I don't know if that one goes, but so if you just type save and then put in a file name with the .mat extension, what it's going to do is it's going to create that file in your working directory. So I have a new .mat file, and it's going to put all of your variables that are in your workspace or in all of the active variables in your script file and put those into that file. So you can actually open these and look at them in sort of like a MATLAB. Did I double click on that? Oh, it's loading it. It just loads it. I don't know, maybe you can't look at it. That's just going to save all of the variables to global pop.mat. So what I'm going to do is I'm going to actually clear all my variables so that I have nothing in my workspace. And what happens now is if I load that file, you can actually do this a lot of different ways. You don't have to use the .mat extension, and you can use the space. But if I load it, all of those variables come back into my workspace. So it's different than the XLS read, where I had to define all of that data to an array. The intrinsic MATLAB data format stores it in a variable, and when you load it back in, it just comes back in as a variable. Does that make sense? So it's a little different. Okay, so the other thing that's nice is a lot of times you don't want everything saved or loaded. So in addition to just doing the whole thing, you can also just say that you want just one of the variables. So if I say load, put the file name, and then put one of the variables or 2 of the variables, then it will only load that one variable in. You can do that the same way when you save. You can only save a few variables to the file. So I could reload everything, and then I could do save global pop AB, and instead of putting that data file in there, I could just put the 2 columns, the columns of data that I defined in the file. And so now I'll have 2 files. One is global pop, one is global pop AB, which just has the other 2. All right, any questions about saving and loading and the native files versus the non-native files before I move on? Okay, so I wanted to show you something before I do a more complicated example, which is sometimes, and I like it, people say like, what is this used for? Why would we ever write this loop? Or what do you do with all of this programming garbage? So I wanted to just show you this file that I just used for like a recent project that I did with Los Alamos. This is a MATLAB script that I wrote to analyze all the data that I was looking at with this ocean modeling project that I was working on. So this is the file that I wrote, and you can see Lots of things are familiar. Like here, look, this is the flag that you guys just did. I'm having flags in here. The other thing that you'll see is some loops. You'll see at the bottom, I have a bunch of things that I did repetitively. So I put them in functions so that I could call them instead of doing them every time. I was going to see if I could find where I read in my data, but it's actually kind of confusing because it's a binary file that I read in, so it's a little bit different. But this is what I did. I wrote this to just analyze the data that I was looking at. And what I did is I have since there's so much data, that file that I wrote just to analyze the data and make plots, that file took about 2 days to just process the data. This is not running the simulations, it was just to process the data. And I had so much data that I actually had to write an automatic script to create all the plots. So this is 105 pages of just my results that was automatically created with a script and made into a PDF. So this is why this is why I find so much importance in automating and programming scripts so that you can do all this tedious stuff, have the computer do it instead of you having to do it. So I just thought that might be interesting to see, like I even write my own plotting schemes. I don't use the intrinsic ones because I think they're kind of ugly. So anyways, I thought that would be useful to see. What we're going to do right now is I'm going to actually solve the quiz. I keep messing up the numbers. Quiz 5. I'm going to do the solution for quiz 5, and I'm going to show you how to import and export data from that as well. Part of the reason I want to do quiz 5 is because I want to show you a couple different ways to do all the different parts, because actually I looked at everyone's solution as you were solving it in class, and no one did it the way that I would have done it, and which is fine. I had an advisor in grad school who I learned a lot of my programming from, and he literally always said to me, with math and programming, he would say, "Oh, that's a one-line solution. That's a one-line solution." And it was so irritating because I was like, that took me like 100 lines to do. And so I'm not going to tell you that you need to be able to write things in one line, but I want to show you that you can write things in one line. And eventually maybe that will be something that you're comfortable doing. So this is an example of that. So in the quiz, you had to start, and almost everyone did this very well, you had to start by writing two functions. So again, this is your main function that's going to call the functions that you wrote. And the second function is going to be your insert function. So there were 3 inputs described in the problem statement, an array, a number to insert, and an index to insert the number to. And then you'll have a new array that'll come out of that, and I think I told you to put that as array new, the new array. So the first thing that you kind of need to think about when you're writing these functions is calling the function, which is sort of maybe not intuitive, but immediately when you're thinking about writing something, your first instinct should be, well, what will those inputs be? Because it's kind of hard to write if you don't have a thought yet of what those inputs would be. So I gave inputs for you to plug in, and so this is just an example of what the inputs could be. This is probably not what your inputs were. So let's say that you had an array X. You wanted to insert the number 12 at the 5th index. So the intention of this function is to put this 12 right here between the 11 and the 15. So you have an array that's that has elements in increasing order, and you want to insert a number at the proper location in the array. So to start the algorithm without having you do it completely from scratch, I said, well, write it so that you already know where the number should go. That's what I wanted you to try first. So this is what you're going to plug in. So let's think about and write out how we might do this algorithm. So this is what I'm going to call option 1. I'm actually going to show you 3 ways to do this, and each way is going to decrease the number of lines probably by about half. The last option is 1 line. So what you're going to want to do is first think, okay, I have an array that's coming in, and I want the new array to be 1 bigger with a number inserted into the proper place. So the first thing a lot of people thought of is creating, pre-allocating array new and making it the same size as array, but 1 bigger. So 1 extra element, but filling it all with zeros. So you're going to just start out with an empty array, and then you're going to fill it in. So now you need to fill in each element. So a nice, easy way to think about most programming assignments and most programs or algorithms is to do loops, because then you're thinking of doing 1 element at a time, which is most natural for most people who are beginning to learn how to program. So I'm going to just set up a loop that's going to go and check each, fill in each element of array new 1 at a time. So the idea of this one would be that you would just create if statements that would determine which value would go. So if I could just switch over to just give you a little demo handwritten, which seems to make sense to most people. So if you have this example here, 7, 11, and 15. The idea is that anything before the index, so if this is the index location right here, anything before the index is going to be the same for array and array new. They're going to be at the same location. And then you're going to have another section where you're going to have the value at the index, and that will need to be filled in with number. And then you'll have another section of anything after the index. So you're going to create an if statement that checks anything before the index, anything at the index, and anything after the index to fill in each chunk of array new with the proper value. So if we set up that if statement here, we're going to just set up anything before the index, anything at the index, and then I'm actually going to use all else ifs because they make me feel more confident, even though it's probably not even possible for that not to ever be run, but anyway. So if I is less than the index, then array new of I is going to equal which elements of array? The I elements, the same elements. So they're not shifted, they're the exact same elements. Then if you're at the index, so array new I here, or you could put array new index, that's going to equal number, right? Because that's the one that you're inserting. And then if you're after the index, then how do we need to shift array? What was it? I minus 1, yeah. So it's kind of hard to think about it. You have to kind of do an example, but 1, 2, 3, 4, 5, this is the 5th one, and you want it to go in the 6th spot, so it's I minus 1, if you give it a try with an example. So this is the algorithm with a loop. So if I want to see if it worked, I'm going to run this file, and I'm going to print both the original X, and I'm just going to let this output print as well. And if I run it, you can see that here's my original array, and then this 12 got inserted in the right spot. I also asked you to give it a try 2 more times, but this time try the endpoints, because depending on how you write your algorithm, the endpoints might not work. So let's try the endpoints. So 1, 2, 3, 4, 5. I want the 6th index to be biggest, something bigger. and then I want the first index to be something smaller. So here I'm going to plug in 17 and -1 as well to see if those two go in the right spot as well. So here's the original one, here's this one on the end, and here's this one on the end. So it's working for both endpoints, and I'm going to assume that it would work for any element in between. Okay, any questions about the loop? Option 1. Okay, so let me now show you how to do this with vector notation. So this is MATLAB's strength. So your goal in learning how to program in MATLAB is to learn how to program in vector notation because it is much faster. It's much more efficient, and it's something that is unique to MATLAB to be able to do that. So I'm going to do it first with, I'm going to just break down each of those 3 if statements and just do it in vector notation. So the first if statement is anything before index. So I'm going to create all of the elements from 1 to index -1. So that's the same thing that this first if statement is doing. It's going to everything before the index, and I'm going to just set that equal to array new, or the original array with the same index. Now I can do the same thing that I did on the if statement. At the index, it's going to equal number, and then everything after the index, so array new index plus 1 to end. So remember, if you haven't seen that notation before, end just goes to the last element of the array. You could also put length of array new if you want to. That is going to equal what index, how do I want to access the index in array? Index plus 1, index -1, what do you think? What'd you say? So index -1 is already defined here, right? And then I already defined index with number. So I haven't used index yet, right? The next one that I haven't used is index. So I went 1 to index -1, and now I'm at index to end. So the way to think about that, if I can switch over really quick with this example. So this index is going in at 5, right? But in the original array, this is the 5th index. So I still need to use this number. So I'm going to do 1 through index -1, then I'm going to define number at index, and then I'm going to reuse array at index to whatever the end of the array is. Okay, so let's see if this works. So I commented out the loop, and I still have the same calls up in the main function. So I should get the same thing where I have 12 going in, 17 going in at the end, and -1 going in at the beginning. So it works the same way. It does the same thing. All right, do you want to see the last one? You so excited? Can you not wait? Okay, option 3 is one line where I'm not going to pre-allocate because I'm just going to go ahead and grab all of these pieces that we did piece by piece, and I'm just going to put them in an array. So it's the same thing, I'm just building the array all at once. And I don't have to pre-allocate because I'm defining it the first time. And let's see if that works. Same thing, the 12 goes in, the 17, and the -1. So the function that I had you write could be written in one line, but don't feel like you should have written it in one line. But that's what I mean. That's what's tricky about programming, especially in MATLAB. Okay, so that was part 1, which I know probably just took me like 20 minutes, but I was explaining a lot of things, and I was talking a lot. So let's move on to the next part of the quiz, which was to create a more difficult insert function. So the next function, this was part B, was to not tell the algorithm where to place the number, but to instead have an algorithm determine where the number should be placed if you want to put it in ascending order. So this just adds a little bit more of a sophisticated thought process to get it to get set up correctly. So step one of this algorithm was just to sort the array. So now the example that I gave you when you called this function was x2, and this array wasn't sorted. So this array was the same array that I gave you in the beginning part, but it was random numbers. And then all you're going to do is plug x2 in and then put in the same z, the original z, but not tell it where to put it. Okay, so this algorithm is, I'm not going to show you multiple ways to do it, but there are a ton of different ways to do it. In fact, I'm almost hesitant to show you the way that I did it because it's probably not a good way, but or there's probably a better way to do it. So the way that I did it is I created a for loop that went through each element of the incoming array. So I'm trying to determine where this number fits in the ascending array. I need to know where it fits. So you could use the find command. That's probably a quicker way to do it. But what I did is I just created an if statement that checked each element of the array and found when the element is bigger than number. So as soon as the element was bigger than number, I saved the index and I break the if statement, which I don't think I've showed you before, that you can break the if statement. This isn't the only way to do it because you could also just save all the indexes and take the first one, but breaking it just stops it as soon as that condition is true. It breaks the for loop, so it leaves the for loop. Instead, you could also create an empty index and keep adding on to the index like I've showed you before, and then just take the first value of that array. That would also work. But that's going to grab the index that it should go to. This works except for the two end cases. So for the two end cases, I'm going to need to pre-allocate index to 1 in case this is never true. And then the other end, I'm going to also check. So if that value that you're putting in is bigger than all the values of array, then index should be the very last value of the new array. But I've never showed you this either. You can highlight code, right-click, and smart indent to fix your indents if you're writing like I am. Oh, they're perfect. Okay. So what I just did is I just wrote a code that located the index. So now I just need to do what I already did, which is readjust array new with that index. So I already wrote this algorithm, so I'm not going to rewrite it. I'm just going to call it. So I'm just going to write array new equals insert. I already wrote this function, so no need to write it again. And then I'm just going to plug in all the values that I already have. So the only additional piece was that find. So you could also just write a find command. I think it's pretty easy. You could just write find array greater than number and then take the first value of that. I think that would just be making this one line of code. So probably should have just showed you that one. Okay, so let's run this and see if it works. So I'm going to suppress all these other ones. So now I have the same x and my new x2 new worked. It put 12 in the same location, but this time I determined which location it was going to go into rather than having it read in exactly. Any questions about that? All right, and then the last piece of the quiz was to write a for loop that was able to just run your code many times. So you could write a new array, which was given in the quiz, that had a bunch of numbers that you wanted to insert. So z used to be just one number, 12, and now this code is going to insert all of these numbers one by one in a for loop. So for this one, you're just going to create a for loop that goes through z2, and it's just going to plug those values into insert 2, and you're going to start with x2, and you're going to index your z2 so that it will grab one at a time. And then what you're going to do is just replace x2 each time so that the new array overwrites the old array. So what that's going to do is it's going to first go and add 1 into the x2 array, and it's going to replace x2 with a new array with 1 in it. Then it's going to take 8 and put 8 in that array, and it's going to do it piece by piece. So what I'll do is run this unsuppressed so you can see it build it. Yikes. J equals J. Thank you. My index is J. Okay, so it's kind of carrying over a couple lines, but here's the original array, and it first inserted a 1, and then it inserted an 8, and then it just is getting bigger and bigger and inserting elements as it goes and replacing it. So the final array is 10 big because it started with 5 and it added on 5. So the new array has all 10 elements on it. Okay, so what I wanted to just show you is how I could redo this, but with reading in data rather than just having this data here. So what I'm going to do is, I'll just leave all this. I don't need to comment it out. So I have some sample data here in 2 different formats, so I'm going to do it 2 ways. So the first way I'm going to do it is using data from a map file. So what I'm going to do is load the data first. The data is called sample.mat here. Now the problem with loading data in a script file or an M file is that you don't have that workspace to look at right away to see what the variable names are. So here's a trick to be able to determine what variables your file knows about. I'm going to load the data as sample.mat, and then I'm going to type the word who. And what who does is it shows you what variables your script file knows about. So it knows about all the variables I already defined in the file and the variables that were stored in the .mat file. So I'm going to comment out everything that I've defined already so that I can just see what's in the file. This should be up here. Okay, so now I have no variables defined in my file at all. So x and y are actually the variables that are in the script file. So that's what it knows about, and so those are the files that, or those are the variables that I'm going to use. So I'm just going to now print them and see what they look like since I know what they are now. So one of them is 1,000 big, and one of them is 100 big. They're really just random integers that I just made up, and then I wrote to a file so that you could see what it looked like. So what I could do is I could write this same loop here, but instead of using those 5 numbered arrays that I already showed you, I can use these arrays. So I'll just put y into x. So I told you that the original one was 100 and the other one was 1,000. So if this works, I should have a final array that's sorted and in order that's 100 and 1,100 long. So here I just loaded in an x and a y and I ran my algorithm on that. So I'm out of time to show you the last one, so I'll just type it up and then I'll end the recording. But that's it. Thanks. What's up?
Sure, this is completely unrelated to the course, but when you use MATLAB, if you write something and you use it for analyzing data, is that yours? Do you have the license or?
Yeah.
Okay.
Yeah, it is.
So I was curious because I had a teacher I worked for, and he didn't want to use it for some reason because he thought if he wrote it as that, it wouldn't be his. But how much is that? Is that that's $5,000?
Yeah. If you buy the professional version, no, it's not 5,000. I think it's like 600.
Oh, okay.
Yeah.
All right. I was just curious.
Yeah.
Okay, cool. Thank you.
What's up?
That function below, you know how you said the element array is greater than the number?
Yeah.
Why did you say that? What's the point of that?
To find, so I'm sorting through this array, and as soon as this number is bigger than the number I'm trying to insert in, I want to save that index because then I know where to put it.
Oh.
So before I knew where to put it, because it was part of the
just
input.
a special sorting technique.
It's the same as like, I guess the find command would do the same thing, but you have to determine where it goes, right? You have to determine which location to put the number at.
In order.
In order, yeah.
Gotcha. Thank you.
Mm-hmm.
Get the email with this attachment?
No, I didn't. From you,
Uh-huh.
I did not. Yep. It's
Makes
Shannon, Shanon. It's also in the syllabus. Dot Reckinger.
The one on the syllabus is yours for sure?
Yes.
Alright, I'll try sending it again.
Okay.
I got connected to the honestly with the 0
Okay.